Karnataka State Natural Disaster Monitoring Center. Karnataka faces many natural hazards. They are classified as follows: climate-related hazards, which include drought, flood, cloudburst, hailstorm, lightning, coastal, erosion, storm surge and cyclones; geological hazards, which includes earthquake, landslide, tsunamis; hydrological hazards, which includes groundwater depletion and aquifer salinity; biological hazards, which includes plant and pest and insect attacks; and human hazards such as plague and bird flu. 80% of the geographical area in the state is prone to drought. 22% of the geographical area in the state is prone to moderate earthquake risks, with the possibility of earthquakes with a magnitude of 5 to 6.9. 24% of the geographical area in the state is prone to cyclone and heavy winds. Landslides do affect the areas with slopes of more than 30%. The 359-kilometer coastal line is prone to sea erosion and tsunami threats. Hailstorms are experienced almost every year and causes damage to crops, human lives and livestock. All the districts in the state are vulnerable to more than one natural hazard. Thunderstorms, cloudburst and lightning causes considerable damage and loss to lives and properties. Seismicity of Karnataka. Compared to the extra-peninsular region representing the Himalayan mountain chain and the extensive plains at its foot, which have been the sites of disastrous earthquakes in the past, the peninsula of which Karnataka forms a part has remained comparatively quiet and has been least affected by earthquakes of great intensity. Greater part of Karnataka falls within Zone 1 and Zone 2, which are affected only by mild tremors, not causing damage to life or property. It is generally true that the peninsula of India, being composed of hard crystalline rocks, is immune to major destructive earthquakes. This does not, however, mean that earthquakes are completely ruled out in this region. No part of the Earth's crust is perfectly stable. The traditional view is that the peninsular shield has remained as a rigid mass unaffected by Earth movements. Recent geological, geomorphological and geophysical evidences do indicate that the peninsula too has been affected by Earth movements somewhat different from those that have affected the extra-peninsula. These movements which have affected the peninsula are slow, upward and downward movements. Landsat imagery and aerial photographs show that the peninsula is traversed by numerous fractures, dividing it into large number of crustal blocks. These, however, have not caused damage to life or property. The Indian peninsula is considered as the remnant of a larger continent which got separated and submerged beneath the Arabian Sea, causing profound changes in the distribution of land and sea. The long straight edge of the Western Ghats is inferred to be the scar which was left after the break and drifting away of the western part of the large continent. The area parallel to the Western Ghats is for this reason somewhat unstable and prone to be affected by earthquake shocks. The disastrous earthquake of Koina in December of 1967 was probably due to slippage along this fault line. Of the three well-defined zones, two zones run approximately parallel to the boundary between greenstone terrain in the north and high-grade terrain in the south, commencing from Mangaluru in the west to Kolar Goldfield in the east. The third zone almost runs parallel to the western margin of Closepate granite. Generally, it is these weak zones which are prone to mild tremors. Southeastern Karnataka experienced a major tremor of 4.5 magnitude on Richter scale in 1984, and the epicenter was located close to Kelamangala near Hosur. The Latur earthquake in 1993 was felt severely in parts of Kalaburgi and Vijayapura districts, and the aftershocks reached as far as south of Bangalore. Subsequently, the Baba Atomic Research Center installed seismographs, one each at Kalaburgi, Afzalpur and Jewargi, and is continuously monitoring these areas ever since. A powerful earthquake of 8.5 magnitude and a giant aftershock of 8.2 magnitude struck in Indonesia in 2012. The tremors were felt in neighboring Malaysia, Thailand, India, Sri Lanka and Singapore. A substantial part of Karnataka and more particularly Mangaluru, Udupi, Mysuru, and Kolar districts experienced this tremor which lasted for about 2 to 5 seconds. The Baba Atomic Research Center installed seismometers at Gauri Bidanuru in Chikkaballapur district in collaboration in 1965. These record continuously earthquakes of even low intensity. The seismic centers at Gauri Bidanur can record the nuclear explosions also, in addition to earthquakes of even smaller magnitudes. Earthquake history. In recent years, much of the seismic activity in the state of Karnataka has been in the south, in the Mysuru-Bengaluru region. Historically, tremors have occurred in many other parts of the state such as Ballari. Recent studies have identified several active faults in the region, in particular in the coastal plain near the towns of Bhatkal and Udupi. The Seismic Hazard Map of India was updated in 2000 by the Bureau of Indian Standards. According to the new map, the state of Karnataka lies in Zones 2 and Zones 3. The coastal districts as well as the northern interior districts along the border with Maharashtra lie in Zone 3. The remaining districts as well as the city of Bengaluru lie in Zone 2. Forecasting, early warning, advisories, and preparedness in management of natural disasters. Disaster management is multidisciplinary and has complexity of information sharing and reporting. It is a common experience that information is not available on a real-time basis to the community and the response players. It takes a long time to obtain the information and a lot more time to integrate and generate the information or reports or the advisories. A study reports that 40% of the time is spent on searching for the source of the information, 30% of the time is spent on waiting for the information to arrive, and another 30% of the time is spent in understanding and customizing to the user's requirement. The Disaster Management Act of 2005 by the Government of India reiterates a paradigm shift in disaster management from rescue, relief-centric approach to preparedness and early warning approach. It is said that $1 spent on early warning and preparedness helps in reducing the cost on rescue, relief and rehabilitation by $7. The investment made on early warning and preparedness has high cost-benefit ratio. It comprises installation of field monitoring sensors, weather, geological, hydrological, collection of data on real time, transmission of the same to a central computational or analysis center, data processing, analysis, alert recognition, simulation through appropriate mathematical models, customized report generation, dissemination of the alerts or reports or advisories to the users. This requires speedy collaboration and close cooperation between stakeholders. What is needed for implementation is sensing the precursor, transmission of raw data, processing of the data, alert recognition, dissemination of warning, weather forecast, and agriculture advisories to the farming community. Keeping the above aspects in mind, the state has set up bodies to deal with these disaster situations. Karnataka State Natural Disaster Monitoring Center. It is an autonomous body registered under the Society Registration Act affiliated to the Department of Science and Technology of the Government of Karnataka. Karnataka State has the distinction of being the first in the country to establish Drought Monitoring Cell, that is DMC, in 1988 as an institutional mechanism to monitor the drought. Activities broadened also include monitoring other natural disasters. The governing body is headed by the Chief Secretary with Development Commissioner as Vice President. It has members comprising line departments and scientific organizations. Natural disasters management heavily depends on inputs from science and technology. Karnataka State Natural Disaster Monitoring Center has been serving as a common platform to the various response players in the field of natural disaster management by providing timely, proactive science and technology inputs. The Master Control Facility will strengthen the activities of the center in providing information, reports, and advisories to the community, research organizations, and the government. The center provides inputs to the farming community, agriculture and horticulture-based sectors, fishermen, transport sector, power and electricity sector, state and district level disaster management authorities in Karnataka through state-of-the-art natural hazards monitoring sensors, information and communication systems. Objectives of Karnataka State Natural Disaster Monitoring Center. This center is providing a common platform to achieve synergy in the field of disaster management in Karnataka. The main objectives are hazard mapping and vulnerability studies, strengthening of information technology for natural disasters management, monitoring and impact assessment of natural hazards, human resource development mainly by imparting training, and natural disaster early warning system. Activities of the Karnataka State Natural Disaster Monitoring Center. Core activities are towards scientific studies related to natural hazards with existing monitoring systems. Maintenance and strengthening the monitoring system is related to natural disaster in the state.